In essence, as a race, we have reached this far. We have discovered fertilizers, we have discovered weedicides, we have discovered insecticides, we have discovered several technologies, but now the time has come where we have to fine tune all of them, because last 100 years was one of the finest period for mankind to make these discoveries, starting from Haber's process to series of discoveries all the way to recombinant DNA technology, introducing engineered virus particles, genetically engineering the crops. Those are breakthroughs which human race has never seen earlier. Yet we have reached a point where we have to think how we can, now since we have reached this far, how we can really precisely use these tools. So the message what I wanted to put across through this lecture is, it's one of the greatest thing what has happened, but now the time has come where we have to utilize each one of these tools. Whether it is a genetic engineering tool, we will be needing it. How much ever we like, dislike, that's our prerogative, individual prerogative, but we have to move on. There is no way to look back. Okay, we'll be needing fertilizers, there's no way. We have to resort to the newer technologies like hydroponics, where you have to use water resources to grow crops. In cities, we may have to use our rooftops all over. We have to use every possible space, because we are living in concrete jungles, where we have to use our rooftop where there is enough sun. We have to ensure the water what we are utilizing is getting purified. We cannot look back. We have to use these chemicals. We have to use some of these insecticide, pesticides. Yet what we have to do is, that's where comes that keyword what I was trying to highlight, is this word, precision agriculture. Precise use and the domain of nanotechnology, what we are going to discuss for next 7 weeks, will highlight continuously to this point that how nanotechnology or these tools can help in fulfilling the dream of precision agriculture for a much more sustainable, healthy society. In terms of precision agriculture, there will be few things which will come very handy for us to realize. One will be optimal use of chemicals. One concept. The second thing, finding out ways more of a less half-life of these chemicals. So less half-life means faster they degrade, and much more these compounds should emulate nature. In other words, nature produces antibiotics. Nature itself does all these things. Could we emulate them so that those compounds should not be a foreign body? We may jack up the use of it, slightly excess, but it should not come as something very foreign, something which nature hasn't seen. We do not want that to happen, right? So, if we play it judiciously, then optimal use of chemicals, as I mentioned here, having shorter, very short half-life of these chemicals, if you could emulate nature, and what we are looking forward to is soil health has to be maintained through this. Water resources clean, healthy water resources. Third, we have environmental in terms of clean environment. All these three things and will lead to a sustainable living. And when you talk about clean environment, I will add one more point: maximizing agriculture in terms of, say, taking the liberty of using this word, urban agriculture, where we are using the rooftops for agriculture, then maximizing agriculture by using hydroponics. Hydro means water, ponics means plant, growing plants in water bodies. Then designing the buildings in order to harvest maximum sunlight. So as to grow as much crops you can afford. Then more of the pot farming, small scale farming, where you are controlling several parameters and you are supporting to a sustainable living. And all these things are eventually is part of that precision agriculture, where nanotechnology can play a very big role. So, as we'll walk through this course, you realize that these are the key points where our discussion will continuously hover around. How we can maximize our productivity, yet not destroying the soil, not contaminating the water resources, and yet keeping the environment clean, and yet on the contrary maximizing the agriculture. So with this, I'll close in for the first week, and in the next week we'll talk about the nanotechnology, the basics of nanotechnology, synthesis, formulations, characterizations, and evaluation methods. Thank you.